This time what we want to do is construct a 100 times 1 minus alpha percentage confidence interval for an unknown proportion. Okay, so what you'll be given in a question like this, when you're doing it, you'll either be given some data, right? And your data will consist of some successes. I'm just going to write S for success, and some failures. Let's see, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and we'll make it an even 10 there. So we'll have some data that will consist of successes or failures. Now, it won't necessarily be the word success and failure sitting there, but it'll be clear in the question what a success is and what a failure is. Or you'll be given some summary statistics. Right? And what those will look like is either you'll be given an X, which is a number of successes, which in this case is 1, 2, 3, 4, 5. Whoops. 1, 2, 3, 4, 5, 6, 7. And you'll be given a sample size, which in this case is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? Or you might be given a p hat, which remember is just an x over n, and you might be asked to figure out what the x is based upon these summary statistics, which is just a matter of multiplying and then possibly rounding that to the nearest appropriate whole number. Sometimes it doesn't come out to be a nice thing there. But you'll be given one of these two pieces of information, and then you'll be told what kind of confidence interval to make, and that's where you'll be given the confidence level. And we'll suppose that we're going to make a 90% confidence level. Right? And the way you're going to go about making a 90% confidence interval for a proportion, right, is you're going to have to compute several numbers. Right? You might have to compute p hat. Right? In some cases, you'll be given it, and then you just use it flat out there. In other cases, you'll have to compute it, which again is just x divided by n, which in this case is there's 7 successes divided by 10 total, which means we get a 0.7 as an option there. Right? You'll also have to compute, right, a two-sided critical value, which in this case, if we look at this guy right here, 90%, that would mean my alpha equals 0.01, and since it's a two-sided critical value, I've got to cut it in half. You know what? It's not 0.01, it's 0.1. And since I have to cut it in half, it's going to be 0.05 there. So I'm looking for z of 0.05, which if you remember, you use the inverse norm to compute that. And the way you're going to do that, it's going to be your area on the left, and that tells you your area on the right. So I'm going to type in 0.95. Then I type in my mean, because it's standard normal, and my standard deviation of 1. So I'm going to look up that number right now. So I'll do second in vars and go down to inverse norm and put in 0.95 for my area. My mean is 0, and my standard deviation is 1. Now you might have a slight difference in your calculator because it might give you the menu. Well, those are the values you type in for those ones. And hit on enter, and I'm going to get 1.64. So I'm going to round it to 2 spots. I'll call it 1.64. Okay. Now the way you're going to make the confidence interval is you're actually going to compute two numbers. You're going to compute a lower number and an upper number. The lower number is going to look like this. It's going to be that p hat minus something called a margin of error. And then you'll have a p hat plus a margin of error. Now the way you're going to compute that margin of error is it's going to, that e is the same thing for both spots. It's going to be that two-sided confidence, that two-sided critical value. And then you're going to multiply times the square root, which is going to be a p hat times a 1 minus p hat all over your sample size. Okay. So in this particular case, I would do the 1.64 times the square root, and now I have to put in here 0.7, and then I'll throw in some parentheses, 1 minus 0.7. Now you could just as well type in 0.3, you don't have to type in the 1 minus 0.7, but I just wanted to make sure you could see the formula being used there. And then I'll hit divided by, and then I have to divide by my sample size, which is 10 in this case. And then I'll just hit enter there, and what that will give me is 2.3, oops, 0.2, we'll call it 0.24. We only have one decimal place here, we'll just go one past it, make our life a little easier for writing this down. So to make our confidence interval, again, we have to calculate a lower value and an upper value. So my lower value is going to be 0.7 minus that 0.24, which is going to be 0.46. And the upper value is going to be 0.7 plus 0.24, which will be 0.94. So we get our two values out of this. Right. Now the easier way to do this, right, is actually to just type it all into the calculator. There's a function that will do this for you. I'm going to slide this up here. And the function on here is called a 1 prop z int. And the way you're going to get to that is hit on second and stats. Whoopsie daisies, I got ahead of myself. Just hit on stat and go over to test. So you just hit on the stat button. You're going to go over to where it says tests, and then you're going to look down there for the 1 prop z int and hit an enter there, and then you're going to just type in the information you have. So I have 7 successes, I have 10 trials. We were making a 90% confidence interval, and I will just say to calculate, and what we get back in this case is 0.46164 and 0.93836. The only reason we have a discrepancy between the two is because we rounded when we did it by hand. The calculator keeps more decimal places. So if you have the calculator do it, this is what we want. This is giving us the exact things there. Nothing wrong with these ones. They're just rounded there. So if you do it by hand versus doing it the other thing and you see slightly different answers on the test, it's just because there was some rounding going, differences between the two ways we can do it. Okay, that's it. That's how you make this.